Hey chat! Let's now work on some sample problems for gravimetry. The first problem we'll look into is not too far off from the laboratory procedure that I showed you, so it should be very accessible as a beginner question. Let's read the problem together. The calcium in a 200.0 milliliter sample of a natural water was determined by precipitating the cation as calcium oxalate. The precipitate was filtered, washed, and ignited in a crucible with an empty mass of 26.6002 grams. The mass of the crucible plus calcium oxalate, 56.077 grams per mole, was 26.7134 grams. Calculate the concentration of calcium, that's 40.078 grams per mole, in water in units of grams per 100 milliliters of the water. This isn't that different from our barium sulfate example. In this case, the analyte is calcium and the precipitate is calcium oxalate. What's different here, however, is that calcium oxalate is not inert. Some calcium oxalate will convert into calcium oxide, so it makes sense to convert all the calcium oxalate to calcium oxide and weigh calcium oxide instead so that we have a pure solid which we could use in our stoichiometry. For problems in analytical chemistry involving multiple steps, it's going to be very beneficial if you write down your given in a flowchart. That way, you can track the logic of the problem and connect the dots as you go along. What do I mean by that? Let me write the given. We're starting with 200.0 milliliters of sample containing calcium. We know that the calcium was precipitated as calcium oxalate. We know that it was burned or ignited in a crucible weighing 26.6002 grams. Yielding a final mass of 26.7134 grams of crucible and calcium oxide. We're asked to provide the grams of calcium per 100 ml of solution. Let me write down the molar masses so that it would be easier later. Calcium is 40.078, calcium oxide 56.077, and calcium oxalate is not required. Alright. For a problem like this, it's very smart for us to start from the bottom and work our way backwards. Again, let's start from the bottom and work our way backwards. We know that if we subtract the empty and the filled weights, we are able to retrieve the grams of calcium oxide. So let me label that real quick. This shouldn't be too surprising for you. Again, we're just removing the mass of the crucible from the final mass containing both the crucible and calcium oxide. Now we have grams of calcium oxide, and since we want grams of calcium, we can just do basic stoichiometry. We know that there are 56.077 grams of calcium oxide in 1 mole of calcium oxide. Since we're looking at calcium, let's track down how the calcium is converted. there's 1 mole of calcium in 1 mole of calcium oxide. I also know that 1 mole, I also know that for 1 mole of calcium, that's 40.078 grams. Here we have a value pertaining to grams calcium, but we need a value of grams calcium per 100 milliliters. So the concentration value is presented in terms of per 100 milliliters. This total amount of grams calcium correspond to 200 milliliters. Alright, so we need to take that into account. If we divide everything by 200.0 ml of sample, our final unit would be grams calcium per ml of sample. But since we want per 100 ml, we need to convert the bottom into per 100 ml. So, if I divide the bottom by 2, that's now 100 ml. I can't just divide the denominator by 2 because the whole expression will be thrown off. I also need to divide the top by 2 so that essentially we're multiplying by 1. Since I need the denominator to be 100 ml, again that's 200 ml divided by 2, I won't include it in my division. Instead, I will just calculate the numerator separately. So that's 26.7134 minus 26.6002, multiply the result by 40.078 divided by 2 and divided by 56.077. The answer is 0.04045 grams of calcium.